Guys, here is your quiz and the answers from the other day. Make sure you're paying attention because you're going to take another quiz that looks very similar but not exact, okay? So looking at this, simplify. Okay, we're going to simplify this. Step 1 is to make a prime factorization tree. So we're going to see what goes into 48. I know 48 is even, so you can cut it in half. 2 and 24. I know 24 is even, so you can cut it in half again. I know 12 is even, so you can cut it in half again. I know 6 is even, so you can cut it in half again, and you're left with this right here. Here's your prime factorization. So bring down the rest of your trees, and there you go. So now we're going to rewrite it. Instead of writing 48, I'm going to write 1, 2, 3, 4 2s, a 3, 1, 2, 3, 4 2s, and a 3, 1, 2, 3, 4 2s, and a 3, and now I'm going to write, I got 2 U's and 2 V's. So there's my prime factorization. Step 2, like on your graphic organizer, that should be in your cheat book, you're going to circle the pairs. Okay? And the pairs go to the outside and they're only written once, okay? So I see a pair of 2's, see a pair of 2's, see a pair of U's, and I see a pair of V's. Now, the stuff that did not get invited to the party or did not have a date to go to the party with, they get left underneath the radical. So that's just plain 3. So now we just got to clean up the outside. 2 times 2 is 4. So you have 4UV on the square root of 3. That had been your answer for number 1. Okay, if you want to check the numbers, you can't check the variables, but you can check the numbers. In your calculator, square root of 48. Let's see if it's the same thing as 4 on the square root of 3. And that's the same thing. So you can check the numbers, you just can't check the variables in your calculator. Okay, number 2, same idea. We got to get the prime factorization of 32. It's even, 16's even, 8's even, 4's even, and now we're just left with our prime factorization at the end. Okay, I got 1, 2, 3, 4, 5, 2. So I'm going to rewrite this. 3 on the square root of 1, 2, 3, 4, 5 2's. And I've got 2 x's because that's x squared. X. We're going to write it caveman style. Okay, now we're going to step 2, circle the pairs. Pair, pair, pair. The pairs get to go to the party, okay? And 3's already at the party, so we're going to write 3 down, okay? And now a set of 2 is joining the party. Set of 2 is joining the party. Set of x's are joining the party. And it's left on the square root of 2 because 2 didn't have a date, so he stays underneath the radical. Okay, we're going to clean out the outside. 3 times 2 times 2. If you don't know it, 3 times 2 times 2, it's perfect to use your calculator. So you're left with 12 on the square root of 2. Now, once again, you can't, x, because you have an x there. Once again, you can't check the variables. However, you can check the numbers. Let's see if those two things are the same, okay? Let's see. Our first thing was 3 on the square root of 32. Square root of 32, and that is this number. And then 12 on the square root of 2 is what we got the answer with, as long as you're looking at the numbers. And the numbers check out. Once again, that doesn't guarantee you get the right answer because the variables may not be the same. But Coach Setzer says take out every 2. Okay, remember that indice or that index is a 2. 2 goes into 2 one time with no remainder, so there's nothing in the radical. So that might help you out as well. Okay, number 3. In your graphic organizer, in your cheat book, it says in order to add radicals, you have to simplify everything first. So I'm going to simplify 50, and I'm going to simplify 40 or 8. So 50, it's even. 25 is divisible by 5. So instead of writing 50, I'm going to write 2, 5, 5. Those are the prime factorization, okay? 2 times 5 times 5 plus 4 on the square root, same thing with 8. I'm going to split in half, and 4 splits in half. So my prime factorization is 3 2's. 1, 2, 3. I'm going to circle my pairs. Pair of 5's, pair of 2's. 5's going to go to the party, 2's going to go to the party because they got a date. Negative 2 is already at the party, so the 5's just joined the party. Okay? 4 is already at the party, and this set of 2 right here is join the party. Okay? 2 didn't have a date at the party, so he stays home in the radical. 2 didn't have a date at the party, so he stays home in the radical. Okay? So now we're just going to clean it up. Negative 2 times 5 is negative 10 on the square root of 2. 4 times 2 is 8 on the square root of 2. So when I'm looking at these, they have the same index because they're all square roots, and they have the same radicand. Okay, square root of 2, square root of 2. So it's just like combining like terms. I'm going to add the coefficients on the outside. Negative 10 plus 8 is going to result in negative 2. Okay, negative 2 on the square root of 2. All right. Your graphic organizer for multiplying, it says multiply the outside by the outside, multiply the inside by the inside. There's an understood 1 here, and there's an understood 1 there. So 1 times 1 are the 2 outside pieces, so that's going to give you a 1 on the outside. Now we're going to multiply the 2 inside pieces, which is 6x cubed and 2x, which is going to give us 6 times 2 is 12, and x, there's 3 x's here, and another x there. So it's x to the 4th, okay? 3 x's, another x makes x to the 4th. Now what you're going to do, or you could write out x 4 times. Now what you're going to do is we're going to simplify this answer right here. Okay, so we're going to simplify the square root of 12x to the 4th power. We don't need the 1 because we know there's an understood 1 on the outside of it. So let's take 12 and break it down. It's even, 6 is even, and now we've got our prime factorization. So instead of writing 12, we're going to write 2, 2, 3, and x, 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 x. Now I'm going to circle my pairs. Pair of 2's, pair of x's, pair of x's. 2's get to go to the party, x's get to go to the party, x's get to go to the party, okay? So 2 got there, x got there, and x got there. And 3 didn't have a date, so we had to stay home inside the radical. Now just clean it up. 2 times x, that's the same thing as 2x to the 2nd power. Okay? So that's how you would do those by hand, okay? The more work you show me, the more credit I can give you. All right, looking at 5 and 6 down here. All right, same thing. 5, you can do it by hand, or you can check out the multiple choice part, okay? So when I'm seeing this, I'm going to do this by hand first. So we got 12. We're going to break 12 down to 6 and 2, 2 and 3. Instead of writing 12, I'm going to write 2 times 3. And I got 2 p's, I'm going to write 2 p's. Circle the pairs, and they get to go to the party. Okay, 2 goes to the party, group of p goes to the party, and 3 didn't have a date, so he stays inside. So you have 2p on the square root of 3. Once again, guys, you can check the numbers. You can't check the variables, but square root of 12, that's the same thing as 2 on the square root of 3. Okay, those numbers match up. If you checked, let's say if you checked 5 on the square root of 5, that does not match, so you should be able to eliminate B. 8 on the square root of an understood 1, well, that does not match, so you should be able to eliminate C. So really, you just have to know how the variables work on that one. Okay, we're going to do this one by process elimination, okay, because I've done a lot of them by hand, and I think you're starting to get the hang of it. First of all, when you're looking at this, they already have the same radicand, so it's like combining like terms. Negative 2 minus 3, we know the answer is going to be negative 5 on the square root of 5 because they have the same radicand. If you didn't know that, what you could do is you could type it in one by one. Negative 2 on the square root of 5 minus 3 on the square root of 5. Oops, let's try this again. Negative 2 on the square root of 5, arrow out underneath it, minus 3 on the square root of 5. Okay, when you get that, this is what it should be. Okay, our answer, 5 on the square root of 5, it matches it. So that's how I'm not going to rule it out. Let's check B. Square root of 13. Negative 13 on the square root of 5. That doesn't match it, so it's not going to be B. Negative 8 on the square root of 5. That doesn't match it once again, so it's not going to be D. And negative 10 on the square root of 5. Okay, and once again, that doesn't match it because that's got a negative 22. So when I'm saying matching it, we're matching it by this one right here. We know that this right here should equal negative 11.180333989. So all I did was just type these answers in to see which one copied that number. That should be a give me, okay? Multiple choice is beauty when there's no variables. Okay, we're going to go to number 7. Number 7, same thing as last time. There's no variables, so you should be able to type the answer and get it out of your calculator, okay? So I'm going to clear out my calculator and square root of 3, get out of the parentheses, is 4 minus square root of 6. Get out of the parentheses, get out of the radical before you start typing anything in. That matches. So my answer should look like 2.685562543. So I'm going to type all my answers in until I get that decimal. So here's answer choice A. 4 minus 15 on the square root of 2 doesn't match. 8 minus 8 on the square root of 2 doesn't match. 4 on the square root of 3, get out of the radical, minus 3 on the square root of 2. Oop, that's a good possibility. Now let's check the last one. Okay, 50 plus square root of 30. And that one doesn't match. So if nothing else, you should be able to go through and just type them all in your calculator until the decimals match. So when there's no variables, it makes it very easy. When there are variables, you can hopefully at least narrow down some of the answers if you look at the numbers. Okay, let me remind you what rational and irrational means. Rational is code for there's a pattern. Okay, decimal ends or repeats, and it can be a fraction. So irrational will be the opposite. No pattern. Okay, decimal never ends, never repeats, and not a fraction. So if you have that, that should help you out with a lot of this stuff right here. Square root of 3. First of all, I don't know what that looks like in a decimal form, so I'm going to type it in, square root of 3. Uh-oh, it's 1.732050808. And guess what? Your calculator, it rounded it off, okay? Because when you're looking at this, your calculator can't type every decimal point is because it's a never-ending decimal. So look, there's no pattern when I looked at this. I couldn't predict this pattern, okay? So this is going to be an irrational number. There's no pattern. Okay? Rational would be 1/3 because look, it's underneath the rational category as a fraction. Because also, if you look at it as a decimal form, 1 divided by 3, that's a repeating decimal. We know that all you're going to get is 3. Okay? Last one, the product of a rational and irrational number. Well, a rational number example would be like 3, and an irrational example would be like square root of 2, or you could either use pi if you wanted to. So let's use pi because a lot of you guys know pi better. And product, we're going to multiply. So if I multiply 3 times pi, well, remember, pi is like 3.14. Let's see what it is. 159.2654, and then it keeps going on forever. Remember the pi chain outside? It's a never-ending decimal. So if you're going to find the product, what you're really going to do is you're going to start multiplying this all by hand. Remember when you did multiplication a long time ago? You're going to multiply by the last term, okay, wherever that last term is. But guess what? It never ends, so you're never going to really end up multiplying the last term by it, okay? Also, thing is you can look at is you can look right here. 3 times pi. Once again, that decimal, it rounded it off because it ran out of room. But there's no pattern to that. So therefore, you're going to be multiplying for it forever. Those digits go on for forever. So therefore, it's going to be an irrational number. I'm trying to give you a better explanation than just memorizing it. But if you have questions, you can send me an email before you start taking your quiz, okay?